Okay, welcome. So this is the last section, and in this section we're going to learn about confidence intervals for variance and standard deviation. So now we've got two objectives. One is to learn about uh, a brand new distribution, which is the chi-square distribution. We're going to learn about that, and we're going to learn how to use TI-84 to find critical values for a chi-square distribution. And the next thing we're going to do is learn how to construct and interpret confidence intervals for a population variance or a population standard deviation. So this part is going to be very similar to what we've done from before. However, finding critical values is going to be kind of new. Okay, so just as a preview and a reminder, so far, when we've wanted to estimate population parameters, we've been looking at four different types of population parameters. And the first one we looked at, which was in section 6.1 and 6.2, was estimating population mean. And the point estimate that we used was X bar. And then in section 6.3, we looked at population proportion. We're trying to estimate the proportion. And we used p hat. Now, it should not be a surprise that for variance and standard deviation, we're just going to use the sample standard deviation and the sample variance as our point estimates. Okay, now let's get into the distribution that we're going to use for our sample standard deviation, for our standard deviations and our variance. We're going to use the chi-square distribution. And the reason why it's chi-square is because when you look at how it's written, it actually is, chi is a Greek letter for what would be X for us, but it's pronounced or spelled chi, but chi. And chi is written like this, and chi is squared. So it's a chi-square distribution. Just as a reminder, the distributions that we have so far, we've got normal distributions, and we've got a whole bunch of normal distributions, and they depend on which one you have, depends on sigma and mu, right? So it depends on your mean and your standard deviation. If sigma is equal to 1 and your mean is equal to 0, then we're talking about the standard normal distribution, aka the z distribution. We also in the last section were introduced to t-distributions. T-distributions depend on the degrees of freedom, okay? And back from chapter 4, we learned about binomial distributions. There are a whole bunch of binomial distributions, and each one depends on the number of trials in and your probability of success for each independent trial, P. So we've got a new one that we're adding, and the new one that we're adding is chi-square distributions. And like t-distributions, they depend on degrees of freedom. So a chi-square distribution, if you notice here, chi-square distribution is the values for a chi-square distribution are always going to be greater than or equal to 0. So chi-square is a positive distribution, right? So all of the values are greater than or equal to 0. We've got degrees of freedom. We're using the same formula, n minus 1. And as with any probability distribution, the area under the curve is equal to 1. So I've even underlined that because it's really important. Chi-square distribution, this is new. It's positively skewed. Okay, so we've been so used to things that are symmetric, but chi-square distributions are not symmetric. They are right skewed. Okay, and as n increases, then chi-squared becomes more and more like a normal distribution. So this is similar to t-distributions, right? When for a t-distribution, as your degrees of freedom get larger and larger and larger, your t-distribution slowly starts to look like the standard normal distribution. It's the same thing with chi-square distribution. So here I have highlighted degrees of freedom equals 30. You have to be up to 30 in order for your chi-square distribution to start to, kind of look like a normal distribution. But keep in mind, for the chi-square distribution, again, because none of the values are negative, it always is between, the distribution is always non-negative, okay? So it's going to be to the right of 0. And you can see if you've got 3 degrees of freedom, or 2 degrees of freedom, which is right here, number one, that means you've got a very small sample size. You've got a sample size of 3, right? So if you have a small sample size, then yep, your distribution is not at all going to be similar to a normal distribution. But as you increase, then you start to have something that's more and more like a normal distribution. And we have in blue here, in blue we've got our standard. We've got this doesn't look like the standard normal distribution. This looks like just any normal distribution there. Okay, so now let's talk about critical values. There are 2 critical values for each confidence level, right? Now remember, C is the confidence level, and C is going to be the area that's in the middle, or the area between your 2 critical values. And we have chi-squared R, which represents the right critical value. So that's over here, chi-squared R. And we've got chi-squared L, which represents the left tail critical value, okay? And so we can get the areas based on using the fact that this area in the middle has to be equal to your confidence level, C. Okay, let's do this example here where we are finding critical values for chi-squared. And this is where I am going to encourage you to stop, pause this video, and watch the video that I've posted online on using TI-84 to find chi-squared critical values, right? So it's on Canvas. So in Canvas, in a module, I think there's a module, it's like towards the top, there's a page, TI-84 videos. There's a module for TI-84 resources, and you just want to click on TI-84 videos and make sure you watch this video first, because it's going to be hard to follow what I'm doing unless you've seen it, actually on the calculator. Okay, so go ahead and watch that video first and then come back and join us here. In the example that we're working on here, we've got the following information. We know that we want a 95% confidence level, so that's going to tell us that C is equal to 0.95. That also gives us this area here, so this area in the middle, right, this middle area here has to be 0.95.
30.
Thank you. So this area in the middle is 0.95, and we're also told that our sample size is 18. So our degrees of freedom are going to be 17. Now, once we know that this area in the middle is 0.95, we can determine the area in the left tail and the right tail. So the area in the left tail is going to be 0.025. I don't know if you can see that. And the area in the right tail is also going to be 0.025. So even though the distribution, chi-square distribution, isn't symmetric, our critical values are based on the fact that the area in between is C. The area in between the critical values is your confidence level. And you've got the same area to the left of your left critical value as you do to the right of your right critical value. Okay, so both of those areas are going to be 0.025. Now, chi-squared L is the value with a cumulative area of 0.025. Do you remember what cumulative area means? It means the area to the left. So the cumulative area for chi-squared L is going to be 0.025. On the other hand, the cumulative area for chi-squared R is going to be 0.09725. And how did we get that? Well, it's kind of easy. We want the cumulative area, right? So we need all of the area to the left. So we need all of this area added up. So we'll have 0.95 plus that little bit of 0.025. So we'll have 0.95 plus 0.025, and that is how we got 0.975 for our cumulative area. And this is going to come into play because when we're trying to find, for instance, let's start off finding chi-squared L, we need to solve the following equation. And our equation is going to be chi-squared StdDev of, now my lower bound is going to be 0, my upper bound is chi-squared L, and my degrees of freedom are 17. We need to solve this for what value of chi-squared L is the cumulative area equal to 0.025, right? So here's where we use our trusty calculator. So let's go into, so we're going to click math. So I'm going to try to write these down, but for some of them, it might not be that helpful. And then for math, you want to go to solver. And on my calculator, it is B is the solver. And then when we go to solver, hit enter. And so you should have 0. So on your calculator, you'll have something that says equation solver. That's what we want to do, is we want to solve this equation. Equation solver. Okay. And then we've got a space to put in the equation. What is the equation? And it starts you off by saying 0 equals, and then you're supposed to put in the equation. In order to turn our equation into something that is 0 equals, we need to subtract. I need to subtract 0.025 from both sides, minus 0.025. Okay, and so now I'll have 0 equals all of this, right? So I have 0 equals, and then this chi-squared StdDev, 0, and then this is what I want is chi-squared L, 17, minus 0.025. This is what I want to put into my calculator. Right, this is the equation that I want to solve right here. So here's how we're going to enter it in. So I'm going to start off, I need to put in my chi-squared StdDev. So go to my distribution, so second vars. So we're going to go to second vars. And then go to chi-squared StdDev. Right, so for me that's number 8. Chi-squared StdDev. And then hit enter. And then for lower, I'm going to put 0. For upper, now I need to give it a variable. And I don't want to put in chi-squared L. That's too complicated. So I'm just going to put in x. And x is right next to alpha. So on your calculator, you'll have second. And then down here, you'll have alpha. Alpha is a green button. And then over here, you've got x, you've got t, you've got theta, you've got n. This is the button you want to press, this one right here. So that's going to put in an x for me. That's what I want. I want an x. And then my degrees of freedom, we said we want that to be 17. And then paste. Okay, so we've got that part in. And now we need to put in minus 0.025. 0.025. Hit enter. And now we want to solve. So how do we tell the calculator to solve? You're going to go to second. So you're going to go to second, and then you want to go to solve. Oh, not second, sorry. You want to go to alpha, actually. So you're going to go to alpha, and then your button down here at the bottom right that says enter, up to the left, above it to the right, it'll say solve, and that's what you want. You want that solve. So we're going to do alpha, enter to get solve. Okay. Give it a moment. And then at the bottom, you should have something that says left minus right equals 0. That's how you know you actually have solved it. And I got x equals, so my answer was x equals 7.564. Okay. So x equals 7.564. Okay, good, good. So this is the same x, right? So it's solving for x. That's what your calculator is doing, is solving for x. So over here, my chi-squared L is equal to 7.54 or 7.56. Now, how are we going to find chi-squared R? Well, to find chi-squared R, instead of going back and going all the way to math, right? Instead of going back to math and then solver and equation solver, a faster way to do it is to hit second, we'll quit, and then second entry. Nope, that's not going to get it. Never mind. We do need to go to math. So let's go to math, and I'm going to go to my solver. And now, when you hit the arrow, the up arrow, when you hit the up arrow, that'll take you to where you can modify your input. So 0x, I'm going to leave the same. My 17, I'm going to leave the same. But now, so I've got chi-squared StdDev. I'm leaving the 0 the same, the x the same, the 17 the same. Now what I need to change is my cumulative areas. It needs to be 0.9725. 9725. 0.9725. And then alpha, enter to solve. What do we get? So this time I got x equals, let me check that, because I got x equals 29.8429. So let me check that. I get 0.97. Because I put in 0.9725. It should be 0.9750. Okay. Let me go to math, solver, clear. Okay, I've got to go all the way back to the beginning because I made an error. So I want my, what do I want in there? I want my chi-squared. So I'm going to go to second vars for chi-squared StdDev. Make sure I do that. My lower is 0. My upper is going to be the variable x. My degrees of freedom is going to be 17. Paste it in. Minus 0.975. So let me erase that. Minus 0.975. Okay. And then alpha, enter to solve. Let me do it again. Alpha, enter. Okay, so I got 30. This looks more right. 30.19. Okay, so this is my chi-squared R, 30.19. Okay, so you want to practice that, be familiar with it, be able to find your critical values because you're going to need them when you are forming your confidence intervals for sigma or sigma squared. So we can see already that we have the formulas, right? So these are the formulas for the left and right endpoints. That we'll need. Okay. So here there's not a shortcut on the calculator to compute. So we have to do it the old-fashioned way. So first, let's read this example. You randomly select and weigh 30 samples of an allergy medicine. The sample standard deviation is 1.2. Assuming the weights are normally distributed, construct 99% confidence intervals for the population variance and population standard deviation. Okay, so let's see here. So the first thing we need to do is verify that the population has a normal distribution. So what is our random variable? Our random variable is weights of an allergy medicine. So allergy medicine weights. Whatever the allergy medicine is, imagine if you could weigh all of the pills, for that, I don't know, maybe it's Zyrtec, who knows, right? Of course, you can't weigh every single pill in the entire world that's Zyrtec that ever was made. So the best you can do is to take a sample, right? A sample of size 30. So we put that in here, n equals 30. And use the sample standard deviation and the sample population, sample variance to create a confidence interval. Okay, so let's verify that the population has a normal distribution. Bam, here we go. Assuming the weights are normally distributed. So that's what we get to assume, is that the weights are normally distributed. And since we're assuming that, then we're good to go. Our next step is to identify the sample statistic n, and we did that, n is equal to 30, and the degrees of freedom. So since n is equal to 30, that means our degrees of freedom must be 29, okay? Now let's find the point estimate, S squared. So this is our sample variance. Well, we know that our sample standard deviation is 1.2 milligrams. So the sample standard deviation is 1.2 milligrams. So our variance is going to be 1.2 squared. 1.2 squared, which is going to be 1.44. 0.2 squared, 1.44, yep. And now I am following, if you're wondering, where am I getting these steps from? Here we go. Verify that the population has a normal distribution. Identify our degrees of freedom. Find the point estimate. Now we didn't need to use this formula because we were given the sample standard deviation in the problem. Okay. Find the critical values that correspond to the given level of confidence. So what is our given level of confidence? It is 99%. So to find my chi-squared L, let's see here, I like to just draw a little sketch to be able to tell.
It's 22:45.
Thank you. So if this middle part is 99%, then this area here must be 0.0. I need 1 minus 0.99 divided by 2. So 0.005. And this must be 0.005. This is my chi-squared L. This is my chi-squared R. So to get my chi-squared L, I'm going to solve 0 equals chi-squared StdDev. My lower is 0. My upper is going to be my variable x. My degrees of freedom are going to be 29 minus 0.005. Okay, and so then I'll get x equals, let's see here, so let's go to Math Solver. And I have to press my up button so I can change what's going on. So I've got chi-squared StdDev 0x. Let me change my degrees of freedom to 29 and 0.005. And then alpha, enter to solve. And so what do we get? It's working. Okay, so we got 13.1211. Okay, and then to find, so this left point is 13.12, and now to find my chi-squared r, I'm going to solve 0 equals chi-squared StdDev 0x29 minus, now I need 0.995, right? Because my cumulative area is going to be 0.995. A good thing about putting this into your calculator is once you do it a couple of times, then if you don't erase it from your solver, it is, you already have it set up, so you just need to put in your, like you'll need to change your degrees of freedom, you'll change your cumulative area, but then other than that, you're good to go. Okay, so 0x29 minus 0.995, alpha, enter to solve. Let me do it again. And what do we get? Took a little bit, but we got 52.3356177786 ... And that's good. So we'll just round that off to 52.33 equals 52.33. Okay. So now that we know we found our critical values, now let's find the left and the right endpoints. So so far we found that our left endpoint is 13.12. And our right endpoint is 52.33. Okay. And then we also know that, well, we can just put this over here. Let me copy and paste. Copy. Paste. Okay. So now let's find our left endpoint. So first we're going to do it for variance. So our left endpoint, the formula for our left endpoint is going to be n minus 1 times our variance over chi-squared r. Okay, and so our left endpoint is our variance over chi-squared r times n minus 1. What is n? N is 30, so our degrees of freedom is 29. So it'll be 29 times, what is our variance? 1.44 divided by 52.33, which is equal to, let me second quit, 29 times 1.44 divided by 52.33. So 0.798. Okay, and now our right endpoint is going to be n minus 1, our degrees of freedom, times our variance over chi-squared L. So it'll be 29 times 1.44 over 13.12. 29 times 1.44 over 13.12. Now we get 3.1829. So our confidence interval is 3.18, comma, wait a minute. We need to have 0.80, comma 3.18. 0.80, comma 3.18. Okay, and so we say with 99% confidence, we can say that sigma squared, which is a population variance, is between 0.80 and 3.18. Okay, and then it'll be very similar for the standard deviation. Copy. Let's see, do we have one more? Let's do standard deviation over here. Paste. Okay. And so for standard deviation, the formula for the left endpoint is going to be square root of this. So I have square root of this, which is going to be, what is the square root of 0.798? Oh, 126, 123. So we have 0.8933155167. So we can say that's approximately 0.90. And then the right endpoint is going to be the square root, square root, square root, square root of 3.1829. So we get 1.78406, which is approximately 1.78. So this would be 1.78, and the top can be 0.90. With 99% confidence, we can say that the standard deviation is between 0.90. What are our units here? Our units are milligrams. So over here, with variance, the units will be 0.8 milligrams squared, and then with standard deviation, 0.9 milligrams and 1.78 milligrams. All right. So we've done a lot. As you can see, it really helps out to have the TI-84 to help us do our confidence intervals very quickly. But, and I'm sure that there are actually ways that you could program your TI-84 to automatically compute the chi-squared confidence interval. And if you want to do that, go for it. And also, share the videos of how to program the TI-84 to do it, because that would speed up this process a lot. Also, if you find a cool video on how to program your TI-84 to compute the chi-squared critical values, share that as well. All right, but we've done all we need to do for this section, and thank you very much.